So this top equation right here defines a polynomial where a and n are variables. So it's just the coefficient of the first term, x to the power of n, where n is the degree of the polynomial, plus coefficient of the second term times x to the power of n minus 1, which is just the, like, if n is equal to 3, then this would be x cubed and then x squared, and then all the way to x, and then the constant is equal to 0. So to find the sum of this polynomial, you would need to do the negative of a n minus 1, which is just the second term in the polynomial, over a to the n, or a n. In other words, this is just the negative of the second term over the first term without the x's, just the coefficients. And to find the product, you do negative 1 to the power of n times a0 all over an. In other words, this is negative 1 to the power of n times the last term all over the first term. And again, without x's, just the coefficients. So for example, if we had this polynomial, 3 times x to the 4 plus 2 times x to the 3 plus x squared plus 7x minus 4, to find the sum, we would take the negative of the coefficient of the second term, which is 2, all over the coefficient of the first term, which is 3. So negative 2 over 3. And the product, we just take negative 1 to the power of 4, because that's the degree of this polynomial, 4 times the constant, which is negative 4, and then all over the coefficient of the first term, which is 3. And negative 1 to the power of 4 is just 1, so it's 1 times negative 4 over 3, so it's just negative 4 over 3 is the product. And that's how you use the sum and product theorems. Let's do an example. If we have this equation, 3x cubed minus 4x squared plus 8x minus 5 is equal to 0, and we want to find the sum and product of the roots, let's use the theorems that we described earlier. So again, the sum is negative of the coefficient of the second term. The coefficient of the second term is negative 4, as you can see, by minus 4x squared. So it would be negative 4 over the coefficient of the first term, which is 3 right here. And negative of a negative is just positive, so this is just 4 over 3. And this is equal to the sum of all the roots. Now let's find the product. Find the product is a little bit more complicated. You need to do negative 1 to the power of the degree of the leading term. So in this case, it will be 3, because right here it's 3, so negative 1 to the power of 3 times the constant, or the last term in the equation. And this one is negative 5, so negative 5 all over the leading coefficient, which is 3. And negative 1 to the power of 3 is negative 1, and negative 1 times negative 5 is just 5. So this is equal to 5 over 3, and that's the product. So pretty easy. We just use the sum and product theorems to find the sum and product of the roots of this equation. Now let's do another example. If we wanted to find the sum and product of this equation, then we would also have to use the sum and product theorems. So the degree of this polynomial is 6. So let's find the sum first. And for the sum, we need to take the negative of the second term, and the second term for this one will be x to the power of 5, since the first term is x to the power of 6, but x to the power of 5 is not written, so it's just 0. And we could calculate what's going to be on the bottom, but it doesn't matter, because 0 over anything is equal to 0. So 0 is the sum. Now let's find the product. First, let's do negative 1 to the power of 6, because x to the power of 6 is the first term, or the biggest term, times the last term, or the constant, which is negative 1. And have this all over the leading coefficient. Here's not written, but it should be 1. Yeah, just 1 down here. And negative 1 to the power of 6 is just 1. So 1 times negative 1 is negative 1. So negative 1 over 1, which is equal to negative 1. And that is the product. So, and notice how, like, even if x to the power 5, x to the power 4 aren't written, we can still figure out what they would be because they would just be 0 since they don't exist. Now let's do some practice problems. If you think you know how to do this one, then pause the video and do it. This problem asks to find the sum and product of the roots of 2x squared minus 3x plus 4 is equal to 0. So first, let's find the sum. And as we know, for the sum for the numerator, we take the negative of the second term, or the coefficient of the second term, which is negative 3x, so negative 3. We don't write the x. Over the coefficient of the first term, or the leading coefficient. In this case, it's 2, so 2. And this is just equal to 3 over 2, which is the sum. And now let's find the product. So for the product, we need to do negative 1 to the power of 2 because that's the degree of this polynomial. So negative 1 to the power of 2 times the constant, or the last term in the equation, which is 4 here, so 4, all over the leading coefficient again, which is 2. So this is negative 1 squared is just 1. So this is just 4 over 2, which is just equal to 2. And this is the product again. So this is a pretty easy problem. You just plug in every single number into the formulas you have memorized. Now, let's do another practice problem. This one has to find the sum and product of the roots of x to the power of 7 minus x to the power of 5 plus 2x minus 9 is equal to 0. And we're missing some terms such as x to the power of 4 or x to the power of 3, but we can still find the sum and product of the roots just given of like equation like this. So first let's find the sum. And we need to find the negative and the coefficient of the second term, which would be x to the power of 6 because the biggest one is x to the power of 7. However, x to the power of 6 is not written, so we can assume it's 0 because it's not there. So 0 over the leading coefficient, which is 1, even though it's not written, it's just default to 1. And 0 over anything is just 0, so 0 is the sum. Pretty easy. And now let's find the product. So again, we do negative 1 to the power of 7 because that's the power or degree of this polynomial times the last term, which is negative 9, all over 1 because that's the leading coefficient. Negative 1 to the power of 7 is negative 1, and negative 1 to the times negative 9 is just 9. So this is equal to 9 over 1, which is 9, and again, 9 is the product. So again, not that hard, even though we're missing some terms inside the original polynomial. Now, let's do one last practice problem. If you think you know how to do this one, then pause the video and try it. This problem says x cubed minus px squared plus qx minus r equals 0 has non-zero roots p, q, and r. Show that q equals negative r and p equals negative 1 over r. And this problem might seem a little bit confusing. You might not know where to start, but since we're given all of the roots and we're given the equation, let's try using the sum of product of roots theorem. So let's use a sum first. So the sum of all the roots would just be p plus q plus r, right? And we can use the formula that we've been using in this video. So negative of the second term coefficient, which is negative p, that's just p over leading coefficient, which is 1, and that's just p. So p plus q plus r equals p, and if we subtract p from both sides, we get q plus r equals 0, and we can change this into q equals negative r. And look, we've already shown that q equals negative r, which is half of this problem. And now let's do the product. So p times q times r is equal to the product of all the roots, which is negative 1 to the power of 3 because that's the degree of this polynomial, times the last term, which is negative r, all over 1, the leading coefficient. This means that p, q, r is equal to negative 1 to the power of 3 is just negative 1. Negative 1 times negative r is just r over 1, which is just r. This means that pq is equal to 1 because if you divide both sides by r, you get right side equal to 1. And now this turns into P equals 1 over Q. And to get P equals negative 1 over R, I can just replace this Q for negative R. And we get P equals negative 1 over R. And now we're done. We've shown both of these pretty easily just using the sum and product of roots theorem. So everything that I explained in this video and all the problems that I went through should teach you everything you need to know about the sum and product of roots theorem. If you learned something from this video, or if you enjoyed it, please consider liking and subscribing.